We're going to begin this lesson with a review of where we've been on the lymphatic system. And one of the first things we talked about with the lymphatic system was that it consisted really of two major divisions. The first one being a lymph fluid drainage system that drains lymph fluid from your interstitial tissues, and then the second being a group of organs and tissues that produce lymphocytes in the body. Now, regarding the origin of lymph fluid, the interstitial fluids have their origin in blood vessels. If this is a capillary here, and that capillary might join together with another capillary, and the blood is moving through this way, the blood fluids here, the plasma component of the blood, some of that fluid will move through the vessel walls, through the capillaries, through the venule walls, and enter the tissues that surround those capillaries and venules. In that area, it becomes what we know as interstitial fluid. This interstitial fluid will move between the different cells and other extracellular components like collagen and other fibers in the tissues, and then eventually some of that will move back into the blood. So there's some of the interstitial fluid that moves back into the bloodstream, but some of that interstitial fluid that's bathing the tissues surrounding that will move into small vessels that collect lymph. So we'll have that interstitial fluid moving into other vessels that collect lymph, and so this is a lymph vessel. And that's going to conduct that lymph fluid back into the general circulation of the body. On this page of your textbook, they show the movement of fluid out of the blood and into the interstitial spaces, and then finally into the lymphatic vessels, the small lymph capillaries that gather up the interstitial fluids to form your lymph fluid that moves through your lymph vessels. Some of the other topics that we dealt with regarding the drainage of lymph fluid, we've already talked about the origin of the lymph fluid. The different lymph vessels that drain the lymph, they're very much like veins. They're like very thin-walled veins. The thickness of the wall is not what a vein is. And they have more valves along the length of each of the vessels there. In addition to this, we should add that along the path of lymph fluid drainage, there are lymph nodes. So all of these vessels pass through lymph nodes. There are two major drainage regions for lymph, one of them being from the thoracic duct, everything below the heart and on the upper left side of the body is drained by the thoracic duct, so below the heart and upper left portions of the body are drained by the thoracic duct. The right lymphatic duct will drain all the upper right quadrant of the body above the heart. All right, next, recall that the drainage system on this side of the thoracic duct comes up and around, joins with other ducts, smaller ducts, and drains in here where the internal jugular and the subclavian meet and lead into the brachiocephalic vein over here. On this side also, the right internal jugular, the right subclavian here, where they come together, our right lymphatic duct comes in and joins here. So this is where all of the lymph fluid that's been drained through all those vessels is going to be dumped back into the blood plasma that circulates with the rest of the blood. This illustration in your textbook shows where the major lymph vessels rejoin the circulation at the junction of your internal jugular veins and subclavian veins, returning lymph fluid to the blood plasma. Now for the lymphocyte-producing organs and tissues, we have a list here of the different categories of lymphocyte-producing organs and tissues. The first two categories, diffuse lymphatic tissue and lymphatic nodules, are distributed mainly along our mucous membranes. And for that purpose, for that reason, we often refer to them as MALT, which refers to mucosa-associated lymphatic tissues, or sometimes you'll see the term GALT, G-A-L-T, referring to gut-associated lymphatic tissues. So that's generally where you'd find these in the loose connective tissues that lie under the epithelium of those mucous membranes in the body. Diffuse lymphatic tissue and lymphatic nodules. We'll get back to those in a minute. Also clusters of lymphatic nodules. So there are some places in the body where the lymphatic nodules gather into groups to form identifiable kinds of organs or tissues. Among those we have the tonsils, we have groups along our small intestine, the lower portion of our lower intestine, small intestine rather, called Peyer's patches, and then also in the wall of the appendix, there's quite a cluster of lymphatic nodules. Next, we have organized organs that have a capsule. They're encapsulated organs that have a discrete structure. First of all, lymph nodes, which are numerous throughout the body, the spleen, and the thymus. So these are identifiable organs that are encapsulated. And finally, we have bone marrow. So all of our blood is being produced in bone marrow, all our different blood cell types. So among those would be lymphocytes. So this is where some of our lymphocytes have their origin. There are clusters of cells that divide to produce our first lymphocytes there in the bone marrow. This picture from the page in your textbook on the lymphatic system shows the overall lymph drainage pathways with the green lines you see in the picture. There are lymph nodes situated in armpit regions, in the groin, in the neck, along the abdominal back wall. It shows the major organs, spleen, thymus. It indicates bone marrow in there. On the right-hand side of the picture is a smaller picture that shows the lymph drainage regions, the thoracic duct region in green with the lower body in the upper left, and then the right lymphatic drainage system on the right, upper right quarter. In this picture, we see three different forms of the lymphatic tissue that might be found along your gut, or your mucosal membranes. The first one here, this is the diffuse pattern, where it may be more concentrated in some areas, but around the margins it's more spread out. I compare that just looking at a place where some beans have been spilled on the floor and they scatter out further from the center. These two examples down here are lymphatic nodules. So this is diffuse lymphatic tissue, these are lymphatic nodules. The first example here is a primary lymphatic nodule. It does not have a pale center in here, so this is a primary lymphatic nodule. These have not been stimulated in an immune response at this stage. This one is a secondary lymphatic nodule, and the middle has a lighter center to it because the cells in here are more actively dividing. They've been initiated into an immune response. That pale center region that we have in here is referred to as a germinal center. Germinal means a point of origin, so there we're beginning some more cells, more lymphatic tissue, more lymphocytes to engage in the immune response that it's been stimulated to affect. Next, we'll show you pictures from the book and from the laboratory to show these three. This microscope slide shows us some diffuse lymphatic tissue in the lamina propria of the stomach. In this region right here, you can see it darker here, all these lymphocytes gathered up, and then they kind of gradually become less abundant as you spread out from them. In this slide, we see a series of lymphatic nodules. Each nodule has a rather spherical, circular shape. These have a lighter region in the middle. They're a little darker around the margins. These are secondary lymphatic nodules. This is in the ileum of the small intestine. This grouping of lymphatic nodules in the ileum of the small intestine is known as Peyer's patches. Now let's take a minute to talk about the structure of a lymph node. The lymph node. The drawing here is the same one we put on the board earlier. We have a similar picture in your textbook that we'll look at. And remember that the lymph fluid going through the lymph vessels passes through a lymph node. So over here we have vessels that conduct lymph fluid into the lymph node. These are referred to as afferent, A-F-F-E-R-E-N-T, lymph vessels coming to the lymph node, and then one leaving the lymph node over here. This is the efferent, E-F-F-E-R-E-N-T, lymph vessel. The entire lymph node is surrounded by a capsule, a connective tissue capsule. On the outside, underneath of that, there's a little bit of space between the capsule and the lymphatic nodules in here. We refer to that as a subcapsular sinus. There are some inroads of that connective tissue of the capsule layer coming into the inside of the lymph node, and these are referred to as trabeculae. I'll label this one here, trabecula. Trabecula. And then on the margins of the trabeculae, we have a little bit of space, and that's referred to as a trabecular sinus. So the fluid moves in, fills this space, the subcapsular sinus, makes inroads into the structure along the trabecular sinus, and then is found in this region populated by a number of lymphatic nodules. So there's a lymphatic nodule, there's a lymphatic nodule, so there's lots of lymphatic nodules in here. And they are located in a zone near the afferent lymph vessels. This zone out here is referred to as a cortex. So I can put a dotted line in here to kind of separate that cortex region from the middle, which is referred to as a medulla. So inside here is the medulla, and outside here is the cortex. So we have a medulla zone, we have a cortex zone. Within the medulla, we have lymphocytes gathered along reticular fibers in here in strands that are referred to as medullary cords. Between the medullary cords are spaces we refer to as medullary sinuses. So medullary cords and medullary sinuses populate the space of the medulla in here. So the lymph node has this somewhat of a filtration-like process where the fluid comes in and moves in and around all these lymphocytes and on the way through, there's some surveillance for foreign materials that could be identified by cells in the lymph node and initiate an immune response and produce more antibodies and lymphocytes that would be effective in an immune response against whatever that invading material or foreign material is that the lymph comes in contact with. And remember, this efferent lymph vessel continues on. It may pass through more lymph nodes on the way back to either the right lymphatic duct or the thoracic duct on its way back to circulation. This illustration in your textbook shows the lymph node anatomy, shows the afferent lymph vessels draining fluid into the lymph node, shows the cortex area with the lymphatic nodules, shows trabeculae in the white coming in from the capsule region, shows the efferent vessels leaving near the hilum or hilus of the lymph node, shows the medullary cords and medullary sinuses there in the center. This slide shows part of a lymph node. Within the lymph node are some lymphatic nodules, seen here, down here, over there, and over there. On the outside, this is the capsule, dense connective tissue. This is a trabecula, separating portions of the cortex here. This is a subcapsular sinus along here, and this is trabecular sinus to either side of the trabecula. This is a portion of the medulla of a lymph node. In here we have regions with dense lymphocytes along strands aggregated around reticular fibers, and then more open areas where fluid is allowed to move through between those dense areas. So the dense areas are your medullary cords, and the more open areas are your medullary sinuses in the medulla of the lymph node. Next is the spleen. Spleen is located in the upper left quadrant of the abdominal cavity. It's up against the diaphragm in the upper back part of the abdominal cavity. It has a surface that is in contact with the kidney as well, and on the front surface it comes in contact with part of the stomach and the large intestine in there, so it's plastered back in against the back wall of the upper abdomen. It's surrounded by a capsule, a splenic capsule. In that capsule are some contractile cells, some myofibroblasts that give a slight contractile quality to the outer layer. There's one location on the spleen where we have the entry and the exit of blood vessels. That's referred to as a hilum or a hilus. The splenic artery comes in and branches out through the spleen, and along the path of these blood vessels, these arteries that go in through here, it branches into smaller and smaller vessels. The smaller vessels out here at the end are surrounded by dense aggregations of lymphocytes. These dense aggregations of lymphocytes are referred to as white pulp. The white pulp portion of the spleen. Between the regions of white pulp are regions of what we call red pulp. The names of white pulp and red pulp come from the condition of fresh spleen. So a fresh cut spleen will have darker areas, darker red areas, and then paler regions within the tissue of the spleen. The pale regions are dense areas of lymphocytes, and then the darker regions have more blood pooled up in it, in what we call splenic sinuses. So blood comes in, it branches out through here, it passes along vessels that go through the white pulp. After passing through the white pulp, these vessels become what we call penicillar arteries or arterioles, and eventually dump the blood out into regions of the red pulp. Those regions of the red pulp are supported by reticular fibers, these regions called splenic cords. And between regions of splenic cords we have small blood vessels that we call blood sinuses in the spleen, splenic sinuses. So we have splenic cords and splenic sinuses that make up the red pulp. So blood comes in through the arteries, branches out into what we call central arteries or arterioles. And then into what we call penicillar arterioles that empty out into splenic cords. So unlike most of our circulation, that is closed circulation where the blood is kept within vessels from artery to vein, here we have the blood kind of dumped into a tissue. It's not contained within a vessel, but eventually that blood will make its way back into the splenic sinuses, which lead into splenic veins, and eventually the splenic veins lead out the other way and carry the blood out of the spleen along passages that follow connective tissues, which are called trabeculae within the spleen. So we have trabecular veins that lead into the splenic vein. So the overall circulatory path of the spleen goes from splenic artery to central arterioles, penicillar arterioles, then it's dumped into splenic cords, which is not a vessel, it's just tissue out there. Then it moves into splenic sinuses. Those lead into trabecular veins. Which leads into the splenic vein. Along the path, the blood is passed through regions with lots of lymphocytes, immune surveillance type cells, neutrophils, macrophage cells, before re-entering into the blood in the splenic sinuses. Splenic sinuses have very disconnected endothelial lining, so there's a lot of space between the endothelial cells to allow these blood cells to move through the cords and into the sinuses very freely. So one of the main purposes of the spleen is that immune surveillance function, very similar to a lymph node, but this time instead of being with lymph, we're looking at blood surveillance, surveilling the blood for any foreign materials. Now, 4 of the functions that we identified for the spleen include, first of all, what we just talked about, screening the blood for antigens and initiating immune responses. Another is phagocytosis of bacteria and cellular debris. Next, removal of blood cells and recycling of hemoglobin, what they call sometimes senile blood cells, older red blood cells are removed. Number 4, blood cell in a platelet reservoir, so storage of some of that blood in case it's needed to be dispersed in the case of a loss of blood or something of that sort. These illustrations in your textbook show the spleen, shows the overall anatomy of the spleen, and the lower left illustration shows a circulatory path in the white matter and white pulp and red pulp of the spleen. You can see how the splenic artery branches into the central arteries that pass through the white pulp, and the penicillar arterioles are not labeled here, but you can see them ending in the splenic cord tissue in the illustration. That splenic cord blood then is returned to the splenic sinuses, the small blue patches in the picture, and then the splenic sinus blood is returned to trabecular veins, which return to the splenic vein in the illustration. This is a region of the white pulp of the spleen, very dense with lymphocytes, and here is a central artery, a central arteriole passing through the white pulp in the spleen. This is a portion of the red pulp of the spleen. In fresh spleen, all of these lighter spaces would be filled with red blood cells, and that's where they get the name red pulp, from all the red blood cells that would be found in there. The areas with more of the blue staining cells, these are mostly lymphocytes and other white blood cell types and reticular cells, those are your splenic cords, and then the white areas are the splenic sinuses. These cells right along the margin of the splenic sinus would be the endothelial cells of this splenic sinus vessel.